This movie is for Learning Target 11. Relate slope to parallel and perpendicular lines. Parallel lines never intersect. Perpendicular lines will intersect at a 90-degree angle. Our first slide, how can you determine if two lines on a graph are parallel? So what we have, parallel lines will have the same slope. So if I find the slope of this line, 1, 2, 3, 1, 2, the slope here is I went down 3 to the right 2. It has a slope of -3/2. If I produce another line, random point, 1, 2, 3, 1, 2, and I go down 3 to the right 2, and create that line, any line that I put on here that has a slope of -3/2 will be parallel to this line. So slopes will be the same. This slope is also -3/2. Parallel lines have the same slope. If we're given two lines and we want to see if they are parallel, we should find their slopes. So the slope of L1, looking at this line right here, I'm going to use these 2 points, x1, y1, x2, y2, and find my slope, which is y2 minus y1 over x2 minus x1. Change in y over change in x. So I'm going to do -4 minus 5 over 2 minus -1. I get -9 over 3, which is -3. Then I'm going to find the slope of the other line of L2, and I'm going to use x1, y1, x2, y2, and find the slope here, y2 minus y1, which is going to be -4 minus 3 over -1 minus -3. So this is going to be -7 over, this is -1 plus 3, which is 2. So I get -7/2. Lines are not parallel since slopes are not the same. Must have the same slope in order to have parallel lines. This you can use for retake contract work. This is another example. What type of transformation on the coordinate plane would result in two parallel lines? Give an example and explain. So let's look at types of transformations. We have translations, rotations, reflections, and dilations. If I put another parallel line on here, this slope is 1, 2, 3, 4, 5, 6, 1, 2. So my slope is down 6 to the right 2, which is -3. So my slope needs to be a -3. And I put a line on here. What type of transformation would result from the aqua line to the blue line? Translation would work because that's just a movement. I just move this over and you can see that I will get an end result of a parallel line. Rotation, you could rotate, depends on what point. If we're rotating about the origin, that would not work. Reflection, if I created a parallel line in between these two with a slope, if I could get a line in between these two with the slope of the same -3, then a reflection would actually work as well. And a dilation is something a little different, where we're dilating, making it bigger or smaller. You could say that you get the same line if the point of dilation is on the line, in which case it would be parallel. Let's look at how we apply this idea of parallel lines. Write an equation of a line that is parallel to this equation, and it must contain this point, so I'll make that x, y. What I need to extract from this equation is my slope. And the slope here is -3. So I'm going to use my slope of -3 in my point, and I'm going to put it in y equals mx plus b. So this would be 8 equals -3 times x, which is -1, plus b. So 8 equals 3 plus b. I subtract 3 on both sides, I get 5 equals b. So that gives me my equation y equals my slope of -3x plus 5, which is my b. Could you use point slope form? Sure. Y minus y1, which is 8, equals my slope, times x minus x1, which would be x plus 1. That would be an equation. I could distribute the negative 3 in, and then add 8 to both sides, and I would get the exact same answer. So point slope form works as well. Pause the movie, try this one on your own, and press play when you are finished. Okay, parallel, same slope. The slope here is -1, and I've got this point. So if I plug this into y equals mx plus b, y equals -1 times x, which is -5, plus b, and I solve this for b, I get b is -2. So my equation is y equals -x minus 2. You could also get that equation by doing the point slope form. Perpendicular lines. This is some investigation that we're going to do in class, but because you're watching a movie, you're not going to be here for class. So let's look at perpendicular lines. Perpendicular lines have negative reciprocal slopes. So let's look at some examples here, what I mean by that. If I have a slope, and then I want to find the perpendicular slope. If my slope is 1/3, negative reciprocal is going to be flipping this and making it negative, which is -3 over 1, which is the same as -3. If I have a slope of 4, the negative reciprocal would be -1/4, because that 4 is really 4 over 1. If I have a slope of -5/3, my perpendicular slope would be the negative of a negative, so it's positive 3/5. If I have a slope of 2/7, my slope perpendicular would be -7/2. If I have a slope of -10, my perpendicular slope would be the negative reciprocal 1/10. So that's how we find if two lines are perpendicular on the coordinate plane, their slopes will be negative reciprocals. Identify if L1 and L2 are perpendicular. How do we do that? Well, we got to find the slopes of each one. So let's get the slope of line 1, which is going to be change in y over change in x, is -4 minus 2 over 0 minus -4, which is -6 over 4, which is -3/2. L2 is, I'm going to do change in y over change in x, so it's -3, I'm using these 2 points, -3 minus 3 over -5 minus 4, which is going to be -6 over -9, which is going to be 2/3. So I'm analyzing these two slopes, 2/3 and -3/2. I can see that the slopes are negative reciprocals. So yes, these lines are perpendicular. Lines are perpendicular since the slopes are negative reciprocals. Here's another problem where you can pause the movie, try this on your own, or use it for retake contract work. What type of transformation on the coordinate plane produces perpendicular lines? Well, if I get the slope of this guy, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So I went up 5 to the right 7. A slope of a line perpendicular would be -7/5. So if I start with a point, let's use that one. I go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. And I connect these. Those are two lines that are perpendicular because they have slopes that are negative reciprocals. Translation would not work for that. I could do a rotation about this point, and it could rotate, so that would work. Reflection, not over a line, and a dilation, we're going to be expanding. So it looks like just a rotation for the type of transformation we would use for perpendicular lines. Here's a classic way of applying this idea. What is an equation of the line perpendicular to this line that contains this point? This is a classic. The first thing we need to extract from this is the slope, which is 1/5. But now a slope of a line perpendicular will be the negative reciprocal, so it'll be -5/1. So I've got to use this slope with my point, x and y, to solve for what the y-intercept would be. So I'm going to do y equals my slope, my perpendicular slope. Note, that's what you want to use, not the slope from this line. And notice the 2 is not something we're going to use. We've got to find the new y-intercept. So I got my slope times 15 plus b, and solve this for b. So I get -4 equals -75 plus b, and I add 75 to both sides, so I get 71 equals b. So my equation is y equals -5x plus 71. Now, to write that in standard form, let's solve this. Y equals -5x plus 71. Let's practice writing it in standard form. To do that, we need ax plus by equals c. So I need the x value on the other side, so I'm going to add 5x to both sides. So I get 5x plus y equals 71. And that actually is my standard form. A and b are not both 0, a is positive, and I've got integer values. So let's just practice writing it in standard form. Pause the movie, try this one on your own, and press play when you are finished. All right, here we have a slope of -3, but a slope of a line perpendicular will be the negative reciprocal, 1/3. We're going to use this point, plug in 7 for y, 1/3 for our slope, -3 for x, and we're going to solve that for b. When you solve for b, you end up with 8 equals b. So my equation is y equals 1/3 x plus 8. That's my slope intercept form. To get to standard, I'm going to take y equals 1/3 x plus 8 and get the x on the other side. So subtract 1/3 x on both sides. So I get -1/3 x plus y equals 8. Couple problems with this. First, I have a fraction, I need an integer, and second of all, I can't have my x coefficient be negative. So what I'm going to do is multiply through by -3 on both sides. By doing that, I distribute in, and this gives me x minus 3y equals -24. Now this is the same equation, it's just I use the multiplication property of equality. This is in standard form because I have ax plus by equals c. All right, and that's all for this movie.